Okay, so in this video we're going to look at our first introduction to a topic called matrices. Now this is going to be a big part of further maths. It's a really useful topic. And all we're going to look at today in this first video is how to multiply the matrices, how to add them and how to subtract them from each other. Okay. Addition and subtraction is really straightforward. Okay, so we'll start with that. One thing we should be aware of is that if you're going to add or subtract matrices, they've got to be the same dimension. Okay, so the same number of rows and columns. So for example, we could add A and C together because this has got 2 columns and it's got 3 rows. Okay, but I would not be able to add A and B together. Alright, and we would call this, we think about it as rows by columns. So this one has 3 rows and 2 columns. So that matrix is a 3 by 2. That matrix is 2 by 2. And that matrix is 3 by 2. Okay, so if we were asked to find A plus C, we could write them out. 2, 5, 0, 4, minus 1, minus 3. And you literally just add the corresponding elements. So 2 plus 6 gives us 8. 5 plus 15. 20. 0 plus 0. 16. Minus 4. Minus 12. Okay, that's basically it. We'll maybe do 1 or 2 more. If we were going to do A plus B, this plus this, we can't do it because they're different dimensions. Okay. If we were going to do 2 lots of B, then 2 lots of the matrix, 2 minus 3, 0, 5. Essentially, when you multiply a matrix by just a scalar quantity, you can literally just multiply the corresponding elements. So that would become 4 minus 6, 0, 10. But to be honest, like it might even be better if you leave it like this with the factor taken out, because sometimes later on in the course we'll do a lot on like factorising matrices and taking out common factors. If you had a matrix like this and they all were even numbers, there's an argument for actually taking the factor of 2 out and leaving it just like this. But just for reference, if you did want to multiply a matrix by a number, you'd be multiplying each of the individual values. Okay, one more quick one. C minus 3a. Possibly pause and have a go with this one. Okay, so we've got C minus 3a. We can multiply inside by the minus 3 if you wanted to, or you could even just multiply inside by the 3 and leave the minus there. And we're going to just think about what the answer is. Okay, so we've got 6 minus 3. Maybe let's not do too much at once actually. Okay, so we've got 6, 15, 0, 12, minus 3, minus 9. Minus, if you multiply inside by 3, we'd have 6, 15, 0, 12, minus 3, minus 9. Notice I've left the minus there. Okay, so then we can see about how to subtract matrices from each other. And actually for this one, if you notice what happens, we would end up with 0, 0, 0, 0. Minus 3, be careful, minus 3, so that becomes plus 3, so that's still 0, and still 0. Okay, so we end up with an empty matrix, or a matrix of zeros. Okay, so basically, yeah, if you're going to add them or subtract them, you just add the corresponding elements, subtract the corresponding elements. If you multiply them by a number, just multiply them inside, all by that number. Okay, we're going to look at multiplying matrices together, and there's a little bit more with that one, so hang fire. Okay, so when we multiply matrices together, the way that I think about it is you multiply rows by columns. All right. So say, for example, if we had a 2 by 2 matrix and we multiply that by another 2 by 2 matrix, the top left element would be the top row, and so the first row and the first column would give us this. This element here in the top right, because it's on the top row, would be the first row, but it's in the second column, so you'd multiply by the second column. Okay, this element here underneath would be the second row, first column, and this element here would be the second row, second column. You may want to highlight this while you're getting used to this in terms of like an algebraic representation. Okay, but we'll see what I mean when we do a couple of examples. Alright, so this element, if you're going to do the top left, do the first row, so it would be A times E, B times G. This next one would be the first row, second column, so it would be A times F, B times H. This one, so it's bottom left, would be second row, first column, C times E, D times G. And the last one would be second row, second column, so C times F, D times H. Okay, so I'd say with a bit more going on with this one, let's try a couple of these. So if we were going to do A times B, then that would be 2 minus 1, 3, 1, multiplied by minus 3, 4, minus 1, 1. Okay, so we do first row, first column, so 2 times minus 3, I might even write this out, so that'd be minus 6, minus 1, so plus 1. Then we do first row, second column, so 2 times 4 would be 8. Minus 1 times 1, so that'd be minus 1. Then we do second row, first column, 3 times minus 3 would be minus 9. So 3 times minus 3, 1 times minus 1, so minus 1. And then second row, second column, 3 times 4, 1 times 1. And we would end up with minus 5, 7, minus 10, 13. Okay. Okay, so part B, we're going to do it the other way around. So we're going to do B times by A. Now you might think, well, when we multiply two things, it doesn't matter what the order is, but let's see what happens. Okay, so first row, first column, so that would be minus 6 plus 12, so that would be 6. First row, second column, plus 3 plus 4. Second row, first column, minus 2 plus 3. Second row, second column, plus 1 plus 1. And notice that clearly when you multiply matrices together, the order does matter. Okay, you probably want to highlight that in your notes. Okay, there's a term for it which it doesn't really come up in the exam, but just in case it does, it's something that you probably want to have reference to. We say that because AB does not equal BA, we say that matrix multiplication is not commutative. Okay, so if they ever mention the word commutative in the exam, we know that basically it means if they were commutative, so normal numbers, like think about the real numbers, 2 times 3 is equal to 3 times 2. And if you're thinking about algebra, A times B is equal to B times A. Like when we're working with like these which represent numbers, but when we're working with matrices, we normally use capital letters as well, and they are not commutative. The normal numbers are commutative, but matrices are not commutative. Okay. So I'm going to do one more. Let's try A squared. Okay. Please do not like think about like squaring the numbers. It's not the same. So like when we're multiplying matrices together, don't forget a squared. What we mean by that is we mean a times by a. Okay. And remember we multiply first row, first column. So that would be 4 minus 3. First row, second column, minus 2, minus 1. Second row, first column, so that would be 6 plus 3. Second row, second column, minus 3 plus 1. Okay. So that's a bit of an instruction about how to multiply matrices, how to add and subtract them. Just one thing to be aware of, right? If you were going to multiply a 3 by 2 matrix, and let's say you wanted to multiply that by a 2 by 4, you would be able to do that. Most of the time in the exam you only multiply 2 by 2s or 3 by 3s, but the way to check is if they match up in the middle. Remember as well, for the description it's rows by columns. So if this matrix had 3 rows and 2 columns, and the next matrix had 2 rows and 4 columns, you would be able to multiply them together, it would work. Okay? And you'd be thinking, well, what would the answer be? Like, obviously, when we multiply 2 by 2s, we end up with a 2 by 2, which is normally what happens in the exam. But in this situation, your answer would be 3 by 4. I'm not going to do that because it'll take too long. Like, I could make one up when we can practice it, but like most of the questions we'll be working with will be 2 by 2s and 3 by 3s. And remember, just multiply rows by columns. But this is just nice to know in case they ever ask something about this. Okay, so let's actually do one example just on what I was talking about then, about the way that we multiply matrices in different rows and different columns. So just to look at what we've got here, we've got 2 matrices with different sizes. This one has got 3 rows, so this is a 3 by 2. And this one's clearly 2 by 2. So just have a little maybe a think about which way we could multiply these together. One will work and one will not work. So for example, if I was asked to do A times by B, that would be 3 by 2 multiplied by 2 by 2. Those in the middle do match up, so it does work. And the answer would equal a 3 by 2. Could we do it the other way around? So that would be 2 by 2 multiplied by 3 by 2. And because these do not match up, we would never be asked to do that in the exam, or we'd have to just say, look, it's not possible, you can't multiply them together. So let's just try and do A times B and see what we get. Okay, so AB would equal minus 2, 1, 0, 1, 4 minus 3. 2 minus 1, 1, 4. Remember, we multiply rows by columns, so first row, first column. So that would give me minus 4 plus 1. Okay, rows by columns, rows by columns. So now we've got plus 2 plus 4. Okay, so now we'll do the second row, first column, 0 plus 1. Second row, second column, 0 plus 4. And then we'll do third row, first column, 8 minus 3. And then second row, second column, sorry, third row, second column. So minus 4, minus 12, that gives us minus 16. Okay. So that's enough, I think, on how to multiply matrices and add matrices together. But don't forget the order does matter, and we can't just multiply every matrix by every other matrix. And if we're going to add them together or subtract them, they've got to be exactly the same number of rows and numbers and columns. Alright, thanks guys.